Problem is related to writing the mechanism. So a molecule is given to you and the product is also given. What we have to do is we have to write down the mechanism for the given reaction. So this compound, so this problem is related to aldehyde ketone. So from aldehyde and ketone, so there is this compound that is given. Here you have a double bond O and here you have a double bond. If you react with H2O2, NaOH, and H2O is also there, and the product found is something like this, epoxide. So this says the treatment of an alpha beta unsaturated ketone. So this is alpha beta position unsaturated. So treatment of an alpha beta unsaturated ketone. So this is alpha beta unsaturated ketone. Everybody knows this is alpha beta unsaturated ketone. So treatment of an alpha beta unsaturated ketone with basic aqueous hydroxide. So treatment with alpha beta unsaturated ketone with basic aqueous hydrogen peroxide yields epoxy ketone. So this is your epoxy ketone. There is a epoxide ring and there is a ketone. So this is a epoxy ketone. The reaction is just specific to unsaturated ketone. So this reaction is just specific only for ketone. Those are unsaturated. So this is a unsaturated ketone. This means there must be one for attack, because if this is just specific to one for unsaturated, this means there should be attack somewhere here. It's not, if the ketone is only there, this reaction does not possible. This means this H2O2, there are some nucleophile that does not attack on this carbon. So, and this reaction is also not given by isolated alkene. So this is also not given by isolated. So if alkene is isolated, this reaction is again not given. So this reaction is only given by alpha beta unsaturated ketone. Propose the mechanism. Now you see, in the basic medium, H2O2 structure is something like this. This will react with OH minus and will form HOO minus, and there is a H2O. Now this is the same thing. If you remember the another reaction also where we prepare H2O2 as an acid. So this is acting as an acid. This is acting as a base. Now this can now act as a nucleophile. So this can act as a nucleophile. So this can act as a nucleophile. So if you have this compound, now there is a conjugate addition, one for attack, OOH. If you want to write, now this lone pair attacks here, this goes here, this comes here. So we will have something like this. Oxygen with a negative charge, there is a double bond here, and we will have OOH. Now everybody knows whenever there is a peroxide bond, we want to cleave this bond. So what we can do is we can return this goes here, this goes here, and then in that case I have to remove this. I cannot flow this kind of arrow. So this arrow is not a right arrow. This arrow is not a right arrow. So let us do, what can I do next? If I do this, I have to remove OOH. So there is no point of removing, we will get the same thing. So what can I do next? O minus. There is a double bond. OOH. Now I have to remove this bond. If I remove this bond, what is happening? If I remove this one, because we have used 1 mole of OH minus, if I remove this with OH minus, there is a positive charge. Now how to remove this positive charge? So can you think something? Just think. If there is a positive charge coming, what it can do? You see, in the product I have to connect this oxygen with this carbon. So this means this oxygen gets connected to one more carbon. That is obvious. There is a positive charge coming, and if I see the product, this oxygen is basically, so you see, oxygen is connected by 2 carbon. 1 carbon already connected. This oxygen is connected by 1 carbon. I have to connect one by more carbon. Once this goes here, now I can do one thing. This double bond can attack here. So there is a plus charge on this carbon. Once this attacks here, at the same time I can remove this negative charge here. So I will have something like this. This molecule, there is a double bond. Now this oxygen will attack here, so there is a epoxide ring. So this is the product. So you see, in this case, only important part is I have to break a OO bond, and once we have used one OH minus as a base, I can remove one OH minus as a, because base is acting as a catalyst, OH minus, and once I remove OH minus, oxygen gets positive charge. This oxygen gets positive charge. To remove this positive charge, I have to attack this double bond. Also there is a hint, because I have to make OCO bond. So I have to make, you see here, OCC bond. So I have to make this bond. So this can be done only if double bond can act as a nucleophile. Double bond can attack here, and once this double bond attacks, there is a positive charge on this carbon comes, and this positive charge can be further neutralized by this oxygen negative charge. So finally we get the product. And this product is epoxy ring with a ketone, so you can call it epoxy ketone. So epoxy ketone is formed when you have a alpha beta unsaturated ketone. This is not possible if you have simply ketone. If you have this ketone, and now if you treat this with H2O2 OH minus, now there is no reaction in this case. No reaction. This is because these reactions happen only if there is a conjugate addition attack is 1,4. So you see, in the above case addition is 1,4. Addition is 1,4, or you can say this is a conjugate addition. Addition is 1,4 or conjugate addition. You know, 1,2 addition, that is a addition here that happens. So if you have a double bond, something like O, if some nucleophile attacks here and this goes here, this kind of addition is called O minus Nu. This kind of addition is called 1,2 addition. In the next step, if I add H plus, I will have OH and U. So addition is at carbon 1 and oxygen 2. So this kind of addition is called 1,2 addition. And this kind of addition, did you remember what is called? This is called direct addition. Okay, we'll discuss some more about the direct addition and conjugate addition in some further question. Let us do some next question.